So here we are with again a new basic topic of ions and radicals. This is a basic topic that you should know. What is the difference between ions and radicals? What are the types of ion? What is the definition of ion? What is the definition of radical? And how to separate ions and radicals. So that we'll study in this video. So let's start with ions. What is ions? From your previous class, the definition is ions are the charged species. Or simply we say that the charged species are called as ion. Now what is the meaning of this charged species? Charged species means species which are capable of reactions, which are capable to do a reaction, which can go for a reaction, that are called as charged species. It differs whether they have positive or they have negative charge. Okay, whatever species that you are getting having positive or negative charge can be categorized as ions, but they are different from radical. How? That we'll study in the later part. Okay, so there are two types of charged species, positive or negative. If it's positive, we call it as cation. Okay, we call it as cation. Negative means anion. Charged species are of two types. First is cation, second one is anion. What is cation? A charged species possessing positive charge is cation, and a charged species possessing negative charge is called as anion. Many examples are there. See, for cation we can write Na positive. Here we can write Ca2 positive. Here we can write Al plus 3. Okay, these are cations. And what are anions? Negative. Like fluoride, chloride, bromide, oxygen -2, nitrogen -3. All these things are called as anion. See, all the anions have negative charge over it, and all the cations have positive charge over it. So simply, if a question is asked what is cation, so you have to write cation are the charged species having positive charge over it. Example, any of the metal you can write. And anions are the charged species possessing negative charge. Example, these are the examples for anion. I hope cation and anion is clear. Now how it is different from a radical, that will study. So for differentiating ions from radical, first know what is radical, then only you can differentiate. So see what is radical. For radicals, three conditions are must. Okay, if even one of the condition is wrong, then don't categorize it as radical, even if one condition is wrong. So first condition for a radical is should have a charge. Okay, this is a must condition. Radical should have a charge. If there is no charge, we cannot call it as a radical. Second one, group of atoms. It should be group of atoms. If it is a single element, then do not categorize it as radical. Then it will be either anion or cation. If there is no charge, then it will be a neutral element. Okay. So for radical, it should be a group of atoms. That is a compulsory condition. Just like it should have compulsorily a charge. Last one is behaves as a single unit. Now this is the most confusing one. This is also a line which most of the students will simply memorize. They don't know what is the meaning of behaving as a single unit. So behaving as a single unit means, see, suppose Y is reacting with SO4. SO4 is a radical. Here I am telling you, after some time we will clarify it with the help of these 3 points. But for now, just remember that SO4 is a radical. So if SO4 is adding to Y, it will never go for YSO3, YSO2 or YSO and some part is left like this. No, it won't go for this. If SO4 migrates, it will migrate as YSO4 as a whole. Okay, let's take that it is positively charged +2 and it is -2. So that charge is cancelled. Okay, so if SO4 -2 will migrate, it will migrate as a whole, not SO4 as SO3 or SO2 or SO. This is the meaning of behaves as a single unit. This is a single unit. SO4 -2 is a single unit. Okay. So wherever SO4 minus 2 will go, it will go as a whole. It will not break into part. It will behave like a single unit. How? See, suppose Na wants to react with Y. So what it will give? It will give NaY. So whole of the Na migrated. Whole of the Na migrated. This means Na behaved as a single unit. In the same way, SO4 minus 2, if it is having a reaction with any of the element or any of the species, it will migrate as a whole. It won't break into parts. Means SO4 won't become SO3 or SO2. It will go as SO4 only. That is the meaning of behaves as a single unit. Now I hope radicals is clear to you. Radicals are a species which are having a charge. They are a group of atoms and they behave as a single unit. If these three conditions are there, then it's a radical. If suppose all these conditions are okay. The second one is not okay for the given species, then you cannot categorize it as radical. Even if one statement out of these three is wrong, it means it is not a radical. Okay, now let's compare it with ions. How to differentiate a radical in ions. Now suppose I am writing Cl negative. We are starting from the basics, okay. So Cl negative. Now I want to know whether it is a ion or it is a radical. So first I will see those three statements. Number first statement is should have charge. Is it okay for Cl negative? Yes, it is okay. So it is having a charge. Second condition we will talk later because this is going to be wrong. Let's talk about third condition. Single unit. Does Cl negative migrates as a whole? It will migrate as a whole. If Cl negative is attaching to suppose X, so they will make ClX. Cl won't break into parts. So third condition is also correct. But second condition says that group of atoms. Is Cl negative a group of atoms? Cl negative is not a group of atoms. It is a single element. Second condition wrong. So Cl negative is not a radical, although two conditions are satisfied. But this condition is not satisfied. So Cl negative is not a radical. It's clear. Okay. Do not think that two are correct. Only one is wrong. So since two are correct, so it should be a radical. Only one is wrong. Do not decide in that way. If any of the statement is wrong, it's not a radical. Now let us talk about NH4 positive. NH4 positive. Is it having a charge? Yes, it is having a positive charge. It is having a positive charge. Is it a group of atoms? Definitely it's a group of atoms. N and 4H are there. Second condition is also right. First is also right. Second is also right. Third one, does NH4 migrate as a whole? Definitely it migrates as a whole. Combine it with Cl negative. As a whole it will migrate and it will make ammonium chloride, NH4Cl. As a whole NH4 migrates. So third condition is also correct. Now see, first is correct, second is correct, third is correct. It means NH4 is a radical, not an ion. It's not an ion. Okay, so NH4 positive is a radical. In the same way, nitrate ion, NO3 negative, it is also a radical because it is having a charge, it is a group of atoms and it behaves as a single unit. Okay. So here I am giving you a question. Just after the question, what you have to do is, you have to pause the video for some time, write the answer in your copy and then after that, check from my video that whether it is correct or not. So I am giving you some radicals like radicals in ions like Na positive, sulfur 2 negative. Then I am giving you SO3 minus 2, okay, CO3 minus 2, and here I am giving you nitrogen. Last one let's take Cr2O7 minus 2. Pause the video and try out of these which one is radical and which one is ion. Add one more, let us write CH4 also. So check out of these which is ions, which is radical. Okay, that you have to check. So pause the video and try it. So now I am solving from here. Now see, what were the points given? ions and radicals. Ions and radicals we have to categorize. So see, first one Na positive, not a group of atom but having a charge. So it will come under ions. Next one, sulfur -2, single S having a charge, definitely it's a ion. SO3 -2, group of atom having a charge, behave as a single unit, so it is a radical. Next, CO3 -2, carbonate ion, CO3 -2 will also be a radical. Nitrogen -3 charge, single, that is why an ion. Cr2O7 -2, definitely a radical. This is called as dichromate ion. Cr2O7 -2. CH4 radical? No. Answer is no. CH4 is not a radical. Why? It is a group of atom. But what about next two condition? Does CH4 always migrate as a single unit? No. Sometimes it breaks. Suppose CH4 reacts with HCl. So it breaks as CH3 Cl. Okay, in this way it will break. So what happened? We see that it got break. Otherwise it would have been CH4Cl. Okay, otherwise it would have been CH4 break as CH3 and H. So this H had a reaction with Cl. Suppose in this way we are making. Okay. So CH3 Cl it made. So did it migrated as CH4? No. Also, if you check the next condition of charge, is it having a charge? No. Charge is also not there. So only one condition is satisfying, that it is a group of atom, and this condition does not decide whether it is a radical or not. Okay, this condition is not sufficient. Neither it is having a charge nor it behaves like a single unit. So simply do not see a group of atom and it's a radical. Check for the charge, check for the single unit condition. Okay, so in this way you have to categorize ions, radicals, and you have to compare them with the help of necessary conditions. So let us summarize today's topic. First one was ions, then its type as anion or cation. Anion is negatively charged, cation is positively charged. Then we talked about radicals. Then necessary condition, there are three conditions. Number one, should have a charge, group of atom, should behave as a single unit. Then we went for the comparison. And for the comparison, you have to check these three conditions. So I hope from today you won't have any doubt regarding ions and radical and their comparison. So keep on studying, keep going. Thank you.